Hello everyone, welcome back to BC Calculus for lesson number 39. We're talking about calculus of polar curves. In the first video we found the derivative of a polar function, and then we talked about how to find the horizontal tangents of a curve. We're going to do the second example today. We're going to find the derivative of r equals sine of 2 theta, given the point 1 pi over 4. And then we're going to talk about doing this problem again, but we're going to talk about the vertical tangents of our curve. So let's go ahead and get back up here to the top. One of the things we discussed in the previous example, I'm going to just do all the space for 2, so we'll get rid of this. So in order to find the dy dx, right, we have to find dy with respect to theta, and then dx d theta. So first thing is we're going to do y. Well, we did this last time where we multiplied both left and right hand side by sine. So let's go ahead and do that. So r sine of theta is equal to sine theta times sine 2 theta. Now, what we have to do here is replace r sine theta with y, and there's really no simplifying that we can do here, just like we could in the first video, so we're just going to leave them alone. And so guys, what we're going to do now is we're going to take the derivative implicitly on both sides, so dy d theta. And we're going to have to use the product rule here, right? So we're going to have to do product rule. So we're going to do the first times the derivative of the second. Well, the derivative of sine of 2 theta is going to be cosine of 2 theta times 2. And then we're going to do plus our second times the derivative of first, which will be cosine of theta. And so theta ends up being pi over 4. So we're going to go ahead and place pi over 4. So sine of pi over 4 times 2 times cosine of pi over 4 times 2 would be pi over 2, plus sine, we just said this, it's going to be now pi over 2 times cosine of pi over 4. So what do we get? Well, sine of pi over 4 is going to be the square root of 2 over 2 times 2 times the cosine of pi over 2 is actually 0. So we can automatically say that this term completely goes away. So then our attention goes straight over to the right-hand side. So we're going to get that sine of pi over 2 is going to be 1, and then the cosine of pi over 4 is going to be the square root of 2 over 2. So this whole thing, dy d theta, is going to be equal to the square root of 2 over 2. So we have the first part of our equation. So dy dx, our numerator is going to be the square root of 2 over 2. So now let's figure out what the bottom part is. So I'm going to go ahead and just erase this part right here and do it again. So if we want to find now dx over d theta, we're going to multiply both sides by cosine. So we're going to get r cosine of theta, and then we're going to get cosine of theta times sine of 2 theta. So left-hand side becomes x, and just like I've said earlier, this does not simplify. And just like I said earlier, we're going to use the product rule on this one as well. So dx d theta is going to be equal to our first times the derivative of our second. So it's going to be the cosine of 2 theta times 2 plus our second, which would be sine of 2 theta. And then we're going to multiply by the derivative of cosine, which is going to give you negative sine theta. So we're going to start plugging values in. We're going to get the cosine of pi over 4. And let's go ahead and just save us some time here. The cosine of pi over 4 is just going to be the square root of 2 over 2. Cosine of pi over 2 is 0. So just like in the previous example, this goes away. So we just look now at our right-hand side here. And we get the sine of pi over 4. Well, pi over 2, right? Because 2 times pi over 4 is pi over 2. So that's 1. And then we get times negative sine of pi over 4 is the square root of 2 over 2. So this ends up being negative square root of 2 over 2. So our denominator will be negative square root of 2 over 2. Therefore, our answer to this problem, dy dx, is going to be equal to negative 1. Lots of work for the problem, but it's not too horrible. It's not too horrible at all. So if you're trying to find dy d theta, you want to multiply the left and right by sine, and if you want to find dx d theta, you want to multiply both sides by cosine. And sometimes they usually just have you guys do one or the other. So down here at the bottom, we talked about this one before. In the previous video, we looked at how to find the horizontal tangents. Now we're going to look at the vertical. And so a couple things that we want to just refresh our memory on is what we did, how we drew this picture. So we're going to go ahead and just draw this picture one more time. And we talked about it as a cardioid. And the reason why now I'm just going to go ahead and do this is that we can see, ladies and gentlemen, that there's going to be two parts, two horizontal tangents, here and here. So for vertical tangents, we said this before, so just a quick refresher one more time. dy over dx, this is our derivative, so we talked about that when our derivative is equal to 0, then that means our numerator is equal to 0. That's how we found our horizontal in the previous video. Well, when our denominator is equal to 0, that means our derivative is undefined. So if we want to find our vertical tangents, that's exactly what we're going to do, is we have to find what dx d theta is, and then set it equal to 0. So we just said before that in order to find dx, we will multiply both sides by cosine. So we're going to get r cosine of theta is equal to cosine of theta times 1 plus sine theta. And we know, again, we're going to have two answers here. So this is going to end up being x. This is going to end up being cosine of theta plus cosine theta sine theta. And now we're going to find our derivatives. So we're going to go ahead and do dx d theta. Cosine of theta is going to be negative sine theta. And we're going to have to use the product rule here. So we're going to do first times the derivative of the second plus the second times the derivative of the first. Which a lot of people already know what this ends up being. So we get negative sine theta, we get plus cosine squared theta minus sine squared theta. Now this is going to be a little challenging for us to figure out how to set this equal to 0, but it's not horrible because we can see that we want this to be sine squared theta. So there's always a lot of thinking that you have to do for these particular examples. So how can I find what this actually is equal to 0? Well, I know that cosine squared theta is going to be 1 minus sine squared theta. So I can replace cosine squared theta with 1 minus sine squared theta. So find the derivative and now start simplifying here. We're going to be given that this is going to be negative 2 sine squared theta minus sine theta plus 1. It's so much easier for us, ladies and gentlemen, I believe, to go ahead and distribute your negative. So just do 2 sine squared theta plus sine theta minus 1. We can factor this thing. We get 2 sine theta. We get sine theta. We get 1. We get 1. This is positive, so this is going to be plus. This is going to be negative. And then we're going to set sine of theta equal to 1/2, and then sine of theta equal to negative 1. And again, we're on the interval from 0 to 2 pi. So using our unit circle values, we know that sine is 1/2 at pi over 6 and 5 pi over 6. And we know that sine is equal to negative 1 at 3 pi over 2. We've already decided that, or discussed in the first video, that 3 pi over 2 does not work because it's not differentiable there. So our answers for this problem are going to be at pi over 6 and 5 pi over 6. If you guys need the explanation for why 3 pi over 2 doesn't work, remember that that's going to be right here. It's not differentiable, therefore we can't have the derivative be undefined or 0 because it's not differentiable in that graph because it's a sharp corner. You have it, guys. Hopefully this makes sense to you, and that's all of our derivatives for polars. And then in the next video we're going to start talking about integration using area. So I'll see you guys in the next video. Take care.